I am Vishwan VM from SVC Department ECE. My topic is superposition theorem with example. Introduction to superposition theorem. Superposition theorem is a powerful tool in electric circuit analysis. It allows us to analyze complex circuits by breaking them down into similar or easier to solve the subcircuits. The theorem is based on the principles of linearity, which states that the response of linear circuits to multiple input source is equal to the sum of responses to each individual source. Next, statement of superposition theorem. Superposition theorem states that the linear circuit connecting multiple independent sources. The response at any point is equal to the algebraic sum of individual responses caused by the each source acting alone, while all other sources are turned off. This means that each source is considered separately, with all sources shorted from voltage source or open current source. The principle of superposition can be applied both DC and AC circuits. Next, mathematical response representation of superposition theorem. Mathematically, the response caused by a single source is found by considering that the source alone and applying the approach circuit analysis techniques such as Ohm's law, Kirchhoff's law, etc. The response caused by the each source is then added algebraically to obtain the total response. This can be expressed as total response is equal to response 1 plus response 2 plus so on response n, where n is a number of independent sources. Look at this figure. Next, example circuit. Let's consider a simple circuit with two voltage sources are V1 and V2 and two resistors R1 and R2. V1 is equal to 10 volt and V2 is equal to 5 volt, comma. R1 resistor 1 is equal to 2 ohms and resistor 2 is equal to 4 ohms. We want to find the current flowing through the resistor R2. Next, applying the superposition theorem. Step 1. Turn off voltage 1 by shorting it, replacing it with a wire. Calculating the current flowing through R2 due to V2 along using circuit analyzing techniques. Let's assume the current is L1. Look at this figure. R1, R2, L1, L2, R3, and next. Applying superposition theorem step 2. Turn off V2 by open circuiting it, calculating the current flowing through R2 due to V1 along using circuit analyzing techniques. Let's assume the current is L2 in the figure R1 and R2 and R3. Next, applying superposition theorem. Step 3. Find the total current flowing through the R2 by adding in the current obtained in the step 1 and step 2. Total current L total is equal to L1 plus L2. Next page. Calculate and result. Let substitute the given values in the previous steps. L1 is equal to 10 voltage divided by 2 ohm is equal to 5 ampere using Ohm's law. L2 is equal to 5 voltage 4 ohms is equal to 1.25 ampere using Ohm's law. Therefore, the total current flowing through the R2 is L total is equal to 5 ampere plus 1.25 ampere, total 6.2 ampere. Result is equal to 6.25 ampere. Next page. Benefits of superposition theorem. Superposition theorem allows us to analyze complex circuits by breaking them down into simple sub-circuits. It provides an effect and symmetric approach to solve the circuit problems. The theorem is particularly useful in the circuits with independent sources where other methods may become. Look at this superposition theorem benefits. Next. Thank you.